Hi students, welcome to this video. In this video now we are going to discuss NEET physics. So in NEET physics now today the topic we are going to discuss is about vectors and product of vectors. So first of all we are going to understood the basic concept, that is scalar quantity and vector quantity. What is a scalar quantity? A physical quantity that can be described only by its magnitude is called a scalar quantity. Okay, there is no direction, only magnitude means then it is called a scalar quantity. There are so many examples for scalar quantity. Some of the examples are length, mass, distance, time, density, work, specific heat, temperature, electric charge, etc. Okay, then we will see what is a vector quantity, a physical quantity that gets completely defined by magnitude and direction also. Okay, so direction is included in vector quantity. Okay, wow. So in addition to magnitude, if direction is also included, then it is called a vector quantity. For example, some of the vector quantities we will discuss: torque, angular momentum. So these are all examples for vector quantities. Okay, so in addition to the vector quantities, now we are going to see the product of vectors. Okay, so already we didn't know about the different types of vector. One equal vector, then null vector or zero vector, then unit vector, area vector, position vector, displacement vector, real or polar vector, pseudo or axial vector. Like that we already discussed. Some laws are also regarding the addition of vector, that is triangle law of addition, then parallelogram law of vector addition, then subtraction of vectors. Like that so many laws we discussed. So now in this video we are going to discuss the product of two vectors. So vector product are of two types. First we will see the dot product or scalar product. Second one, cross product or vector product. So dot product or scalar product, first of all we will discuss. So it is also called scalar product because the result is a scalar quantity. So now let us consider a vector and b vector are two vectors, and theta is the angle between them as shown in the diagram. Okay, so a vector dot b vector is equal to ab cos theta. Right, so A is equal to modulus of A vector. Similarly, B is equal to modulus of B vector. There are some properties regarding the scalar product. For first one, it is commutative. A dot B is equal to B dot A. Okay, so then distributive. A into B plus C is equal to A dot B plus A dot C. Okay, wow. Then if a scalar quantity is multiplied, for example, M is a scalar quantity, M into A vector dot B vector. This is equal to A vector dot MB. Like this we can write. So if a unit vector is taken, n cap is a unit vector, then n cap dot n cap is equal to 1 into 1 cos theta, that is equal to 1. Okay, some formulas are also there. That is I dot I is equal to 1, then j dot j is equal to 1, k dot k is equal to 1. So in the case of orthogonal unit vector, I dot j or j dot k or k dot I, this is equal to 0 because I dot j is equal to 0, I dot I is equal to 1, but I dot j is equal to 0. So like this we are studying the properties of the scalar product. Okay, wow. Now how to find theta? Theta is equal to cos inverse A divided by AB. Okay, wow, right? Cos theta inverse A vector B vector divided by AB. Then we will discuss about the cross product or vector product. So it is also called vector product because the result is a vector quantity. So the formula is A vector cross B vector is equal to AB sin theta n cap. Okay, wow. So how to find sin theta in this? So as given in the diagram, sin theta is equal to modulus of A vector cross B vector divided by AB. Here also some properties are also discussed. So the first property is commutative. So here the commutative law does not hold good because A vector cross B vector is not equal to B vector cross A vector. Okay, the vector product is distributive. Similarly, if a scalar quantity M is introduced, then M of A vector cross B vector is equal to M A vector cross B vector. Like that we can write. Then here also if we consider unit vectors I, J, K, then I cross I or J cross J or K cross K is equal to 0. Okay, I cross I is equal to 0, J cross J is equal to 0, K cross K is equal to 0. But I cross J is equal to K, J cross K is equal to I, K cross I is equal to J, right? So in like this we should memorize the formulas. Okay, so the A vector cross B vector, it is written in the matrix form. It is also given here. So IJK in the first line, second line A1 A2 A3, third line B1 B2 B3. So here A1 A2 A3 B1 B2 B3 are the components of IJK unit vectors. Okay, right? Then we are going to discuss about the application of the product of the two vectors, right? So the first is how to find the area of a parallelogram. So the area of the parallelogram is given by the formula modulus of A vector cross B vector. The area of a triangle half A vector cross B vector. The area of a parallelogram with the diagonals A and B means then half into modulus of A vector cross B vector. There is a identity called Lagrange's identity. If A and B are any two vectors, then modulus of A vector cross B vector squared plus A vector dot B vector the whole squared is equal to modulus of A vector squared into modulus of B vector squared. Some examples we will discuss. First is work done in linear motion. So work done is an example for scalar product. Then in rotational motion we are discussing about the formula for work done is equal to tau into theta 2 minus theta 1. Okay, or in simply tau vector theta. Okay, then another example is energy, right? So energy is given here. The kinetic energy is given. Kinetic energy formula K is equal to half mv squared in linear motion. In rotational motion K is equal to half I omega squared. Okay, therefore half I omega squared is a scalar quantity. Then another example for product of vector is torque. So then the formula is given here. Tau vector is equal to r vector cross f vector. Another example is angular momentum. Angular momentum L vector is equal to r vector cross p vector. Here p vector is nothing but linear momentum. So already we know the formula. P is equal to the product of mass and velocity. So the corresponding diagram is given here. So now in this video we discussed about the properties of the scalar product and the properties of the vector product, and some of the examples are also discussed. So these examples and the properties, it may be asked in NEET exam. Okay, so you must be thorough with this topic. Then only it is easy for you to know about the product of different types of vectors. Okay, right? So you observe this video clearly, like and share this video and subscribe my channel also. Thank you.